Hi, and welcome to Allen High School's discussion of bonding at the AP and IBHL 1 level. We're moving into organic, kind of bridging inorganic and organic molecules here. And so far in our conversation, we have been ignoring double and triple bonds. And we're going to address them at a fairly introductory level. The first bond formed between two atoms is called a sigma bond. And in a sigma bond, the electron density is centered between the two atoms. Now, the second and third bonds formed are called pi bonds. Pi bond is formed when we have extra p electrons. For example, if we have an sp hybrid, that means we had two atomic orbitals, p orbitals, that in theory, that region in space is available for electron movement. And that's what is used in this model. The electron density in this case is centered either above and below, and we'll want to look at animation that I have, a little video clip that I have of this. So please remind me to show you that video clip in class. Or, so that would be if we used, say this was an atom and this was an atom, and that would be the above and below, and the electron kind of moves in the space that kind of forms between above and below. Now, but remember, we also have one that kind of goes in front of and behind the atoms, and I'm not going to be very good at trying to draw that, but hopefully this gives you that idea that these could be used and bridged, and so it could be in front of or behind. Both together. It's not either or. It's either above and below or in front and behind. Now, you can't have a pi bond unless you start with a sigma bond. So we're going to be counting these, and you need to be careful, especially when we're doing web assign with organic molecules, because they're often not drawn fully. And in fact, organic chemists will show butane this way. And they'll assume you know that's butane because you'd know that there are carbons at each of these points. And I think we saw some of those earlier in the year. So we want to, before we count sigma and pi bonds, we want to fill in this kind of sketched out model. So there's carbons at each of these points. Additionally, you have to make sure all carbons have 4 bonds. And if they don't have 4 bonds, you need to add 1 to hydrogen. Very common to leave off hydrogens. And so that's the one. If you count all the other carbons, there's 4 bonds. Now, this CH3, you want to be careful because it represents a carbon with 3 hydrogens attached to it. There we go. So that would represent 3 sigma bonds there. Likewise, this is going to represent 3 sigma bonds. So let's first count our sigma bonds. First bond formed, so there's 1, 2, 3, one between the nitrogen and the hydrogen, 4, 5, 6, 7, remember 8, 9, 10, one to each of those hydrogens, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, I think I'm getting 22, so I'm going to have you double check for me. So that would be 22 sigma bonds, and I am sure there's going to be somebody coming into class to tell me if I'm wrong. But hopefully you get the idea there. Now, let's take a look at our pi bonds. For our pi bonds, we count just the second bond. So that's 1, 2, 3, 4 pi bonds. So that one I think I've got pretty good. I'd like you to double check that for me. Now, let me show you a common organic molecule. So just put this on the side, but I do expect you to have this as your notes. Benzene ring is a very common molecule for dealing with pi bonding, and it really has a unique structure. So it has alternating double bonds with hydrogens. Now, some of you may have guessed already that benzene displays resonance, because there was really no reason why, and I'm just going to sketch out, just kind of do an organics type sketch. I could have put the double bonds here. So if we have equal energy possibilities, this is, remember, resonance. Okay? And there are hydrogens off here as well. Now, with resonance, it's not like it's an equilibrium between these two flip-flopping back and forth. Benzene actually exists as a hybrid. And so to show those double bonds, we use a circle like this. So instead of a bond order of 2 and 1, we end up with, so here we would have 3 bond orders of 2 and 3 bond orders of 1. Instead, what we see in terms of the strength of the benzene, we see the bond order equal to 1 1/2. Right? Because that double bond is effectively shared. So if you want to calculate it, we have 9 bonds. So 6, 7, 8, 9 bonds shared amongst the 6 carbons. So that's a bond order of 1 1/2. And because the ring is like this, when we have alternating double bonds like this, so with an alternating double bond, and you want to write this word down because it's important, it's one you've heard about in a different context, we say we have delocalized. Okay, that the electron density is delocalized. It's not fixed between 2 atoms. It has a region over which it can move, a broader region over which it can move. So that's pi bonds and sigma bonds. If we wanted to go ahead and count this one, we would see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sigma bonds, and then the 3 pi bonds. Now, I want to go back for a moment to that previous structure here and talk a little bit about hybridization. That valence bond theory is hybridization, and I would say one of its most common usage, sorry, that's a N, not a M, there we go, valence bond theory. One of its most common usages is with organic chemists. So what they would do is you would define that, for example, as a center, and I would define that as 1 carbon with 3 things branching off of it. So that would be an AB3 around that carbon. And if it, so that's 1, 2, 3, right? So if it's AB3 around that carbon, we would say that that carbon is sp2, right? If B plus X is 3, I need an S, a P, and a P. So it's sp2 hybridized. Now, this carbon here has 4 things, the nitrogen and the 3 hydrogens. So we would say that that carbon, since it's an AB4 structure, we'd need an S, a P, and a P. So we would say that this carbon is sp3 hybridized. Okay? And we could talk about the nitrogens as well. Anything we can define kind of as a center. All right? So that's another, I think, important consideration that you're going to see when you do some of your WebAssign in class. So until then, this is signing off.